This side of the triangle is 24. So, I need to know the third side of the triangle if I want to hope to find all the possible trig function values. So I'm going to do the Pythagorean theorem. So I'm going to do negative 7 squared plus 24 squared equals c squared. So that's 49 plus 576 equals c squared. That gives me 625 equals c squared. So c equals, when I take the square root, 25. So that gives me the hypotenuse. And I am going to be working with two different angles here. So this angle, alpha, that's the measure of the angle in my reference triangle. And then this angle here, theta, that's the measure of the angle that I'm actually overall looking for. So if I'm just thinking about my reference triangle, I'm not even going to deal with any negative angle measures, any negative side measures. If I just think about this triangle, 7, 24, 25, it's a nice Pythagorean triple, and this angle alpha, I want to find all the trig values. I want to find the measure of the angle alpha, and I want to find out what the different trig values are. So if I want to find the measure of angle alpha, what I'm going to do is I am going to pick my favorite trig function value, let's say tangent, and I'm going to write the tangent of alpha equals my opposite over my adjacent. So to find alpha, I'm going to do the inverse tangent of 24 over 7, and then I'm going to use a calculator to evaluate that. And I'm going to start with my calculator in degree mode. And I'm going to do the inverse tangent of 24 divided by 7. And I get a value of 73.74. That value is in degrees because I put my calculator in degree mode. Now I'm going to change my calculator to radian mode. Usually you just have to find the mode button on the calculator and then switch it from highlighting degrees to highlighting radians. And I'm going to repeat the exact same calculation, the inverse tangent of 24 divided by 7. And then I get that alpha is 1.29 radians. So those are my two different values of my reference angle. Those reference angles, though, those aren't the value of theta. Because you can see theta is bigger than 90 degrees, bigger than pi over 2. So what I have to do to get theta in degrees, I'm going to do 180 subtract 73.74. Which is 106.26 degrees. And in radians, I'm going to do pi, or 3.14, subtract 1.29. And that will give me the value of theta in radians, 1.85. But I still haven't answered the question, which was to find the trig values for the angle. So actually, just finding the trig values is a lot simpler than what I've done, but I wanted to go over how to find the angle itself. But finding the trig values, so for the sine of theta, so this is the big angle, not just the reference triangle. So I am going to use the positives and negatives that I see. Sine is opposite over hypotenuse, so that is 24 over 25. Cosine is adjacent over hypotenuse, so that is negative 7 over 25. And tangent is opposite over adjacent, so that, which we already used, is 24. But this time we're going to use the negative 7 because we're dealing with theta. And these are the different trig functions for theta. And then down here I have the values of theta in both degrees and in radians. All right, our second problem is going to be if I know the value of one of the trig functions and I know whether the other trig function is positive or negative, can I use it to find the other trig values? So I'm going to draw an angle that has a cosine of 5 over 13 and a tangent that is less than 0. Now, if you recall this handy acronym here, all students take calculus. That tells us that in the first quadrant, all of the trig functions are positive. In the second quadrant, sine is the only one that is positive. In the third quadrant, tangent is the only one positive. And in the fourth quadrant, cosine is the only one that is positive. So in my example here, cosine is positive, but tangent is less than 0, so tangent is negative. That tells me that I'm going to be living in the fourth quadrant. If tangent had been positive as well, then I would have had to been in the all positive quadrant or the first quadrant. But since tangent was negative, I must be living in the fourth quadrant. So what I'm going to do is I'm going to draw my angle, which has a cosine of 5 over 13, which means my adjacent side is going to be 5, and my hypotenuse is going to be 13. And here's my reference triangle. Theta actually refers to this angle here, measured from the positive x-axis in the counterclockwise direction. My reference triangle, alpha, has an angle there. And then my other side, my longer leg of the triangle, I can find using the Pythagorean theorem, keeping in mind that 13 is the hypotenuse. 13 is the hypotenuse, so I have 13 squared equals 5 squared plus b squared. So that's 169 equals 25 plus b squared. So then I subtract 25 from both sides, and I have 144 equals b squared, so that b equals 12 when I take the square root of both sides. Since 12 is b, I can put the 12 here, but because it is going down, because I am below the y-axis, I need to note that it is actually negative 12. And that will cause the tangent to be negative, as I am supposed to get based on the instructions in the problem. So now it's going to be pretty easy to find the other trig values. All I need to find are the sine of theta and the tangent of theta. The sine of theta is the opposite over the hypotenuse, so that's going to be negative 12 over 13. And the tangent of theta is the opposite over the adjacent, or negative 12 over 5. If I wanted to take this a step further, I could go ahead and actually find out what theta is. I could do the inverse cosine of 5 over 13 and use my calculator, and I'm going to do it in degrees. When I do this in degrees on my calculator, the inverse cosine of 5 over 13 comes out to 67.38 degrees, but that's the measure of my reference angle. That's alpha. So to then find theta, I have to subtract that from 360 degrees to get the measure of theta, which gives me 292.62 degrees. I can repeat this process again in radians to find alpha. So I would just go back to my calculator, I would switch my calculator to radian mode, and I would redo the inverse cosine of 5 divided by 13. That gives me an angle of 1.17 radians. And then to find theta in radians, I'll subtract from the full circle, which is 2 pi, or 6.28, to get the measure of theta in radians, which will be 5.10 radians. I hope this helped. Good luck.